the new problem? Big number is almost impossible. Do it by hand. So what is the idea? The idea is a matrices. It's a matrix. What is the matrices? Matrices en plural and matrix en singular. Like the movie. Do you see the movie Matrix? Oh no?
No.
No. It's no big deal. Now, definition is a rectangular. Matrix is rectangular. Rectangular array of numbers. Entonces, for example, si you have this system of linear equation, I don't want to complicate 25, no, I put only 3 equation and 3 unknown. This movie is a classical movie, guy, Matrix. Of course, I don't like, but it's a classic. Minus C equal minus 2. So we have 3 equations and 3 unknown, X, Y, and Z. Now, the fantastic way for solving this is using matrices. Entonces now, according to the definition of the matrix, rectangular array of number. Entonces you write like that. So far, we study, I promise that we study 3 different ways to face linear system of equation using algorithms. 3 different. And the first one that we study is the augmented matrix. Augmented matrix. Augmented matrix is easy. You copy some book. The majority of book using a square bracket. Some book using parentheses. I don't like parentheses. However, in the software, okay, I want to use it because I consider it the better for the students. Okay, by the way, is GeoGebra Classic. This is free in internet. You can download or no. You can working in the cloud. It is totally free. And I recommend that you create an account. So you put a username and password and linking with the email. But okay, it doesn't matter. I at the beginning I working online, but it was much better if you download in your own computer the version. So it's the same. So now you're working. Maybe you. What is the advantage and disadvantage? And the computer is fast, and you can save your work in the file inside the computer. And in the cloud, no. In the cloud, it's a little bit depending the speed of your internet, and you save your work not in your computer, you in the cloud. Okay. Either way, you make a decision with the way you prefer. But let's come back to augmented matrix. What is augmented matrix? You copy only the coefficients. For example, in the first column, 1, 2, negative 3. What comes from this? This is the X column. 1, 2, and negative 3. You copy negative 2, positive 1, and positive 4. It's the column of the Y. The column of the Z is 3, 4, negative 4, sorry, and negative 1. And you separate with the one line. Okay, this line we are using in the paper. However, in the software, no. In the software, you put together everything together. But I would like, this is traditional, separate the left-hand side and the right-hand side. So on the right-hand side, we have 4, 3, and -2. This is called augmented matrix because it's a combination of the number in front, coefficients in front each variable, and a right-hand side number, no? Okay, have no variable. And you need to keep in mind that this is X column, Y column, and Z column. And this is the right-hand side numbers. And this is called augmented matrix. And this is the way that we need to work in, right? You need to work in. First of all, I want to explain in detail how you are doing by hand. But by hand is horrible. It's more organized. It's more systematic. But it's too many computation and everyone making mistake in one number and one sign, and you screw up everything, right? Therefore, definitely we are doing only one problem by hand because I would like you see the procedure, the algorithm, and after we solve the software, using the software, I want to teach how we manipulate the software, right? Manipulate the software. Entonces now, oh, it's easy, professor. No, it's not easy because sometimes it's tricky. Suppose this system. This is example 1. I suppose I bring example 2, que it's confusing. I create to confuse you. Suppose que one equation is x plus y equal 20. It's equation 1. Equation 2 is z plus y equal 40. It's given in that way. And the last equation is x plus 2y plus 3z equal 60. Equation 3. This is the system. It's possible that way. Sometimes happen that one variable in the equation is missing. No frequently, but sometimes happen. Entonces, I need to warn you in this condition how we create the augmented matrix of the system. No? And remember, the organization is clear. Look, extremely important organization because it's too long process. You have a column of the x, but you don't need to write this. This is auxiliary thing that I am doing. So to visualize the idea, no, and the right-hand side number, right? And the first equation, the equation number 1, the coefficient in front of the x is 1. The coefficient in front of the y is 1. It's missing z, so you put 0, and the right-hand side is 20. This is my first line, my first row, row 1, que represent equation 1. And row 2, somebody doing very disorganized, put a C first. But x is missing, 0x, 1y, 1c, and this is 40. This is my second row que represent the second equation. And the third row is easy because everything is present. 1, 2, 3, and 60. Of course, when you finish that, if you want, no mandatory, you erase that part, and this is the guy, and basically this is the matrix, the augmented matrix, of course. I want to start the process, right? Now, important. And the language of the matrix is the dimension. Dimension is the number of rows. You put it by one symbol can indicate like a multiplication, but actually it's no multiplication. Number of columns. Entonces now, in this case, we have 3 rows, 1, 2, 3, and we have 4 columns. The column of the x, the column of the y, the column of the z, and the column of the right-hand side. Because that was the augmented matrix, is a combination of the coefficients in front of the variable attached, augmented by the right-hand side number. So far it's clear? Everyone follow me? Everyone understand very well?
Yes.
Now, in this lecture, I want to explain two algorithms to solving the system. The first one is called Gauss elimination. Gauss elimination algorithm or method. And the second is the continuation of the Gauss. Gauss is the last name of the most important mathematician in the history, Gauss. Another case, a complementary is Gauss-Jordan. Gauss-Jordan, o sea, Jordan is another mathematician que complement or continue the idea of the Gauss. Entonces, Gauss-Jordan elimination. Entonces, everyone in the world, when you're talking about Gauss elimination or Gauss-Jordan elimination, understand very well what are you talking about, no? And what is the difference between this? Okay, I want to explain in a few seconds. Okay, when you apply the algorithm by hand or computer software, we transform it. For example, this example one, I want to retake in this example one, this matrix, and you are doing something inside this, on this matrix, and you convert in this way. Let me show you. You convert in this way. So a lot of arithmetic, you convert to this. -2, 1, 0, 3. Don't worry too much because I want to explain the arithmetic. Now I want to explain the goal for the method. Suppose this. So you doing something that you don't know very well so far. On the original matrix, you convert to this. Okay, so the idea is very basic. We have always one here, one, and this one is called pivot. So in the first column, you select the element, the entry, in the top. You need to do something to create one. Actually, we have no one in the original. Look, is yeah, one. Okay, nice. It's a coincidence because of the elementary example. Not always happen, but it's a pivot number one. And below the pivot number one, we are doing several operations in order to get 0, 0, 0, 0. Suppose we have 25 equations. 0, 0. We have 24 0. And 1, 1 in the pivot. Bam, 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 bam to 0. This is 25 equation. This is the idea. After that, when you finish the first column, you go to the second. In the second column, you take the second pivot, que is this. This is the pivot number 2. And below, you put 0, 0, 0. So it's basically 1, 0, 0, 0, 0, 0 to the last 0. After, I don't care too much this number. You put 1 in the second pivot, and you create 0, 0, 0. And so on. Okay, I don't care that number. I don't care that number. 1 is the third pivot, pivot number 3, and 0, 0, 0. And so on. So you have 25. We continue 1, 1, 1, 1. This is Gauss elimination method. And the new matrix is obtaining using this technique. So this matrix is called let me erase this. It's called echelon. echelon form. And the reason is echelon is because look like stairs, like that. Echelon. This is the name, guys. I don't create this name. It's the name in any book you can see. Okay, so now when you are doing this action, maybe by hand, I want to explain in your moment, but we need to study another thing to understand by hand. Or using the software, you get the echelon, and the echelon is super easy to solve because we can apply back substitution. What is that? Well, remember, this is X, this is Y, this is C, this is the right-hand side number. Therefore, you take the last row, the row 3, number 3. Es obvio que 0x plus 0y plus 1z is equal to. Therefore, es obvio, es elementary que C es 2. So this is 0, this is 1 que es invisible, C is 2. And we are doing back substitution. We go from the bottom to the top. You go now the second equation. The second equation is y, the coefficient is 1, minus 2 times z, pero c is 2. Entonces 2 times 2 is 4, negative 1 here. Entonces y minus 4 equal negative 1. Y is equal negative 1 plus 4, que es 3. Okay? And finally, in order to find the x value, well, back substitution. Again, you take now the first row, and the equation for the first row is x minus 2y, but y is 3, plus 3 times z is 2, equal 4. That's the equation, the row number 1. Okay, number 1, row number 2. This is x, this is 6. And it's by coincidence, it's 6. It says 0, x equals 4. And the solution is the triple order 4, 3, 2. This is one way. It's a one way. Maybe the question that fly in the air is, Professor, I don't understand how you go from this matrix to this matrix. I promise I want to explain in a few seconds, but it's long and complicated. So this arrow to convert to go to echelon form is too long. Okay, but don't worry, we practice. In the review package, of course, we have an example of this. Let's move on to the Gauss-Jordan, okay, the continuation of this. The continuation of this. Using another algorithm, okay, it's Gauss-Jordan elimination method, you can convert again our original matrix in another matrix. Okay, it's different to the echelon. It's like that. Let me show you. It's 1, 0, 0, 4. And they are equivalent 100% algebraically. 3 and 0, 0, 1, and 2. And this is, again, the dimension is 3 by 4. I forgot here, 3 by 4. It's the same dimension because this is the same matrix. They are equivalent, represent the same system, but I change the coefficients using the magic Gauss elimination or Gauss-Jordan elimination method. Entonces, in this case, this new matrix is called reduced echelon form. And the acronym we are using in some calculator, in some graphic calculator, is to do this method is REF. And this is RREF. But in And the GeoGebra, que es the software that we are using now, it's called different. Okay, entonces, what is the idea? Bueno, the idea is super. Look at the first row, or either row. Row 1 is the first equation. It's 1x, because this is the column of the x, this is the column of the y, this is the column of the z, plus 0y, plus 0z, is equal to 4, no? Entonces es obvio que 0 and 1 is, this equation is just x equal 4. Likewise, in the row number 2, que is the second equation, is y equal 3. And the row 3, que is the third equation, is c equal 2. And we get exactly the same result. It's fantastic. Of course, this way by hand is too long because it's the continuation of the Gauss elimination. Jordan, the thing I do in Jordan is Gauss, take a pivot and create 0 below. Bam, 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 bam. Suppose 25 equation. Now take it, the second pivot, and Gauss continue doing something in order to create 0 below, and Jordan doing below and above in both directions. Now the third pivot is here. Gauss do 0 below, and Gauss-Jordan doing below and above, and create the famous reduced echelon form matrix. Guys, this is fantastic. It's the perfect way to organize this. Another way, no. Why no? Because you are doing a crazy algorithm. Maybe one work you are doing previously is affected. No, this is completely independent. You work it column by column in both directions or in one direction. Either way, so you are doing one direction, so you need to apply finally back substitution. Oh no, nobody doing this. In the real life, you apply Gauss-Jordan, and you get directly who is x, who is y, who is z, who is w, who is, okay, the 25 there. Do you understand the idea? Okay, so what is the foundation behind this? Well, the foundation behind this. Yes or no, guys? Do you follow me? You have some question? Yeah? You are in holiday already? You follow me? He said, Jenny said, I follow me. Okay, Jenny? No question? Okay, no question. Okay. Now, what is the idea? The idea behind this is you perform one thing is called row operations. Row operation. Que essentially is the same row operations. Let me delete this as row operation. Essentially is the same thing that we are doing in elimination, pero more systematic, more organized. So now, let me explain the row operation. We have 3 basic row operations. Only 3. Row operation number 1, que is you can interchange. Interchange. 2 row. Entonces, basically, of course, we can do that. You have a system. You have 25 equations. And 25, oh no. But who says what is the first, what is the second? No. If you want, you can interchange. You put the equation 25 in the first place, if you want. And the equation number 1 in the 25 place. Because maybe it's convenience for me. So you can interchange. To say now you lost the idea that we are solving a system of equations, and you focus in the matrix, que the matrix is the rectangular array of the number. So now You don't see X, Y, Z. You don't see the variable. You say, what's the way to solve that? You say, now we can, if you want. Not always, but you can. So, for example, let's do an example to understand interchange to row. Suppose, and the symbolic way to indicate this is row 1, interchange, double arrow, row 2. Suppose, to understand, because it's too easy, it's no big deal. Suppose that we have a matrix like that. I don't want to complicate too much in the example. You put 2 by 2 or 3 by 3 to do by hand. And the rest, no, by hand or with calculator. Suppose I have this matrix. Let me erase that part. Okay, by the way, the dimension of this matrix 2 by 3, no? 2 row, 3 column. Okay, maybe this belong to the one system that contains 2 equations. Remember, the number of rows always is equal to the number of the equation. The number of rows in the matrix is equal to the number of equations. And the number of columns, bueno, no, is equal to the number of variables plus 1. Because you attach the famous right-hand side. No? Okay, so this belongs to the one hypothetical linear system of equations. It contains 2 equations and 2 unknown. Yeah, I want to perform the famous row operation interchange to row. Well, it's too easy. It's elementary. It's instead of row 1, I put 3, 2, and 17, and 2, negative 5, and 5. Done. I did the row operation. Okay, this is easy. This is straightforward. Everyone understands very well this. Suppose the second row operation, okay, is when you multiply. Okay, it's exactly we are doing elimination. No? Multiply a row by, bueno, non-zero number. I suppose you remember when we solve the system, you say, well, no, I like to elimination. So you multiply by -2, the equation number 1, okay? This is legal, perfect legal, because this new equation after the multiplication is totally dependent of the region. It's equivalent 100%. In the matrix language, we have, for example, this matrix again. I copy using the same example, no? Here I perform this operation. You multiply by 3, because I don't know why. Professor, you select 3. Why? It's just example to illustrate the idea. But after I want to explain in detail what is the most convenient factor that you select in the multiplication is suppose R1 store in R1. Entonces I introduce this notation. It's important to understand the row operation. You have who has R1? R1 is a row 1, and capital row 1 is the same row 1, but after the multiplication. What does little r is the given row, capital R is the new that you obtain after the operation. But when you multiply by 3, row 1, the entire row 1, we have 6, negative 15, 15 positive. And row 2 stay the same because actually in the operation that we are doing nothing about the row 2. The row 2 stays the same. The only row that change is the row 1. Okay, you multiply by 3. Maybe you don't understand much better now. Why 3, Professor? Well, no, it's just example. I put 2, I put 3. Any factor that you need in the process. And the operation number 3 is the most popular and most complicated to understand. So frequently, 99% of the time, we are doing the operation 3. It's add and multiply, add a multiple, a multiple, a multiple, a multiple of one row to another row. Let me translate this to the English, more clear. Suppose again, okay, we have the same matrix. 2, 3, -5, 2, 5, and 17. It's the original matrix, but I want to explain the new row operation. And the symbolic way to indicate this. I suppose a factor 2 multiplied by R1 plus R2 and store this information in capital R2. What means that? Can you take any element in the row 1, get this? You multiply by 2, 1 by 1. You adding with the corresponding in the same column of the R2, and this new number you store in the row 2. Entonces now es obvio que R1, o sea, row 1 participate in the game, but doesn't change because the only row que change is the R2. Let's do it. You multiply 2 times 2 is 4, and 4 plus 3 is 7. Do you understand where I come from this 7? This 7 comes from, look, 2R1 plus R2 storage in R2. So you put it here, 2 times 2 plus 3. And store in R2. These two, these first two is a factor que ahí select. It's a multiplier que ahí select. This R1 is the first entry here. I multiply 2 times 2 is 4. And plus 3 is the corresponding in the same column, and the answer is 7. Likewise, 2 times -5 is -10, plus 2 is -8. No? Let me explain again, clear. Okay, it's the same operation, but participate different number. 2 stay because it's a common multiplier using in the definition of this row operation. No? Multiply by -5 plus 2. This -5 is this, and this 2 is this, in the same column. Entonces -10 plus 2 is -8. Cool. And finally is 2 times 5 is 10, plus 17 is 27. Okay, the idea is the same. 2 times 5, this 5 is this 5, plus 17 is 10, plus 17 is 27. The important thing is that little by little, using these elementary operations, interchange to row, multiply by one number, or the most powerful get multiplication by one factor, and adding, you try to go to this Gauss elimination method or Gauss-Jordan elimination method. Do you understand, or is not clear? Do you understand, or is not clear? The final goal is not clear. The final goal you can see clear in this example que bring now, que es too long. But I promise it's the last one que I do by hand. The rest, everything we are doing by software, the algebra class. Do you understand the basic idea? Is confusing something, or I need to clarify something, or no? Question, come on. Attendance good. I believe que attendance not good because it's giving. Kind of think I need more practice. No. Okay. Okay, Jenny. Of course, we don't finish. Now you see in this example, the next example, we see more clear. But the problem is, after today, we're working every day with this. So of course, practice is enough that we have. Okay, let me erase everything. Yeah, I will go to the big problem in which you can see everything together. You can see row operations, you can see Gauss-Jordan elimination, and you can see Gauss elimination and Gauss-Jordan, both. Because Gauss elimination is one intermediate step inside the problem, no? So suppose I have a system of equations, and immediately I write in the piece of paper a matrix 4. Suppose this is. By the way, this is the system that contains 3 equations because I see in the matrix 3 rows and 3 unknown, que is x, y, and z, no? On the right hand side. And row 1, row 2, row 3. 3 equations. Remember, the number of rows corresponds with the number of equations. And you know very well how we translate the system language. Okay, we have the habit to see in that way, and this new way can allow us create a software specific for this. Okay, so now I explained before that you need one pivot. The first pivot is located here. I need to create, and the first pivot is 1. It's very useful to be 1. CS3 you can work it, but it's complicated. Now I propose you, well, you divide it by 3 maybe, but if you divide it by 3 you complicate your life, because you divide it by 3 the entire row 1, 3 divided by 3 is 1, nice, but 7 over 3 is a fraction. Hello, no good. So we can take advantage. In the first transformation you interchange row 1 and row 2. Why not? Because I see in the row 2 1 here. Oh, I appreciate so much that help. Then my new matrix is 1 2 -4 -3 3 7 -15 -12, and nobody touch the row 3. Stay the same. Totally the rest. But what's the goal? The goal is I have my famous people, okay, my friend, can help me to continue. You follow me? I need the people. Any people is 1. Some books are doing different, but I prefer it that way. Now, completely now. What is the next transformation? The next transformation, remember, according to the Gauss elimination, is you have a pivot, create 0 here, 0 here, in that position. I try to use it red color. Here. And when I finish this, after 0 in this position, I finish my first column. Okay? Let's try. Using imagination and common sense. Now, you apply 1 row operation, pero the complicated row operation, the number 3 row operation. The factor que I select, the multiplier que I select is -3. Why -3, professor? Because it's the same value, but opposite side. Let's see why. You multiply the row 1, que is the row in which we have a pivot, plus addition the row 2, que is the row que want to change, and this new number I put in the row 2. Okay, entonces I copy The disadvantage to do by hand, well, it's horrible. It's que you need to copy. In the software, no. In the software, you are doing one step. But it's okay. Entonces, row number 1, stay the same, participate in the game, but doesn't change because the only row can change is row 2. And row 3, no change because I never touch. No participate in the game, I never touch. Okay, so now I multiply -3 times the pivot, no, times any element, any entry, it's the technical name, element of entry, and the matrix is called entry. Inside the matrix, I'm adding with the corresponding column. So for example, -3 times 1 is -3, plus 3 is 0. I get that. Likewise, -3 times 2 is -6, and -6 plus 7 is 1. Do you follow me? You understand where I come from this one? I need to explain more clear?
Yes.
Okay, cool. Now, likewise, -3 times -4. So we navigate column by column, guys. Is positive 12, and positive 12 minus 15 is -3. And last, -3 times -3 is positive 9, and positive 9 minus 12 is -3. Boom! I finished the first transformation. The goal was to get that 0. This is the goal, to get that 0. Okay? 0. And I know it's too long. After that, 1 0 here. After that, 1 pivot here, 1 0 here, and 1 here, and you finish Gauss elimination. And Gauss-Jordan, no, Gauss-Jordan is below and above. But let's do it. This is no big deal. I select one elementary example. In the real life, this is the only last time we are doing this. Do you follow me the idea? Question. Jenny say yes. Okay, let's continue. What is the next step? I need to create 0 here. What should I do to get 0 here? Well, I create a fantastic, and this is part of the game. Okay, you need to create by yourself your own row operation in order to get the thing you want. The thing you want is positive 4. Oh, but why positive 4? Well, because it's the same number and opposite sign. And you multiply by R1. Why R1, Professor? Because the R is the row that have a pivot. And the pivot is the mother to create 0, 0, 0, below. Plus R3 and store this new number in R3. Okay, I understand. Now, let me make it zoom to see more clear. Now, the row 1 stay the same, nobody touch. Participate in the game, but nobody change. The row 2, well, I did in the last step, but not now. The only row that change is the row 3. Okay, obviously is 0. Where come from is 0. You multiply 4 times 1 is 4, plus minus 4 is 0. Now, 1, no, 2, so 4 times 2 is 8, and 8 positive, minus 6 is 2. Do you understand this 2 where come from? You multiply 4 times this 2 is obvious 8, positive 8, positive 8 is this answer, plus R3 is minus 6, together is 2 positive. Okay, likewise, 4 times -4 is -16, and -16 and positive 15 is negative 1. Now, the last is 4 times negative 3 is negative 12, and negative 12 plus 16 is 4. Oh, you know it's too long, but the only thing I am doing is in the column number 1, I create the pivot 1, and below 0, 0, 0. Suppose we have 25, 24. 0 is too long process, no? Okay. The problem is that I have too long whiteboard. It's infinity whiteboard in both directions. And the physical whiteboard and the campus, I need to move into the another line. Okay, so I finished the first column. Good, I like that. I move on to the second column. But the second column, I appreciate so much that one pivot is already created. Supposing another example more complicated, que no one is 5. Entonces, I don't know, we need to do something to create one. Entonces now, remember below the pivot, que the factor is -2. Why -2? Because it's the same number 2, but opposite sign. Multiplication by R2, que is now the row que contain the pivot, plus R3. Storage in R3. Okay. Okay, entonces then, I copy, row 1, and row 2 doesn't change, stay the same. However, row, and this is 0, and this is 0. Look. You multiply -2 times 1 is -2, plus 2 is 0. But what happened here? You multiply -2 times 0 is 0, plus 0 is 0. Well, this 0 que I get, que I force, I apply my energy, doesn't affect when you are doing. This is the optimum algorithm to we are doing progressing step by step. Doesn't affect my previous work. So you select another order, you are in big trouble. No good. Big trouble. Now let me try the next. The next here is multiplication. -2 times -3 is +6 minus 1 is 5. And -2 times -3 is +6 plus 4 is 10. Cool. I create my pivot number 2 and below 0. What is the next step? Suppose you continue doing by Gauss-Jordan. So now I need to create the third pivot here. So I propose you the following operation. You take the row 3 and divide it by 5. Or multiply by 1/5, get the same, and storage in the row 3. So we have 1, 2, so the row 1 stays the same, nobody touch. 0, 1, -3. And when you divide it by 5, the row 3, 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. Oh, this is my goal, create the third pivot, 1. And 10 divided by 5 is 2. Wow! This is now the moment in which I have echelon matrix. And echelon matrix we can solve it using back substitution. And back substitution is, I see this is the column of the X, this is the column of the Y, this is the column of the Z, and the last equation I saw que C is 2, and the second equation I see que Y minus 3Z, que 2, is equal -3. Therefore, Y minus 6 is equal -3. Y is equal -3 plus 6, que is 3. And C x, sorry, is x plus 2y, pero y is 3, minus 4, and c is 2, should be 3, minus 3. Entonces x plus 6 minus 8 equal minus 3. X is, in this case, subtraction, is minus 2, no? Equal minus 3. Therefore, x alone is minus 3 plus 2, que es negative 1. And the solution is the solution, the triplet order. The triplet order x equal negative 1, y equal positive 3, and c is equal positive 2. You write like that if you want all like a order pair, like a triple order pair. Negative 1, 3, comma 2 as a solution. And so far, the only thing I am doing was apply several row operations. You transform it little by little in another equivalent matrix, and you get so you apply Gauss elimination, and you get echelon matrix, and you apply back substitution. Entonces, I don't want to continue, but you trust me. So you are doing, let's do it quickly. No. Suppose que I want now continue perform. You continue the process. You continue the algorithm, but doing the Gauss-Jordan. And Gauss-Jordan is que in the pivot below and above. So, for example, one way is for example to make 0 here and 0 here and 0 here. You need to apply the following operation. No? You need to apply the following operation. Look, you apply, suppose that I take the pivot number 3 and you multiply by positive 3, R3 plus R2, and you store in R2. I don't want to do a step by step. I only suggest the operation that you should do is several steps. And I want to put the final answer. No, the next is 4, because this number but opposite sign, R3 plus R1 stored in R1. And so now doing this and this operation, I put 0 here and 0 here. Of course, the other number change in the row, no? And the only guy I need to change is these 2. But these 2 is easy. Using the pivot 2, you multiply by negative 2, R2, because remember, the multiplier, you apply in the pivot plus R1 and store in R1. And magically happen when you apply this row operation, you are doing step by step, one by one, in either order, you get this answer. 1 0 0 0 1 0 0 0 1. In the right hand side, we have negative 1, 3, and 2. Wow! So this so far was Gauss elimination, and these 3 more is Gauss-Jordan elimination. Entonces you see now super clear, crystal clear, que x is negative 1. Look in this equation, no? Y is positive 3, and c is positive 2. Do you see or no?
Yes.
It's really amazing. Do you see before in your life this? Somebody explained this in the teacher in the high school?
No.
No, never. Wow. I don't know what happened. In the high school, the teacher don't want to complicate this. But this is the correct way, the professional way. Nobody see before this? Come on, opinion. I want to see opinion. Edward, no? Gladys, no? Jenny, no? Never. Wow. Okay. Entonces, the question is, this is hard? No. This is long. In the long procedure, yeah, Jenny said no. This is hard? No, it's not hard. It's long. In any long procedure in mathematics, you make one stupid mistake, no 2 plus 2 equals 5, you know, one sign, 2 plus 2 equals 4, but you put negative 4 because you put negative, I don't know why. Yeah, the answer is wrong. So this is the disadvantage. To say now, nobody doing this by hand. I want to explain using software, right? So I want to solve this in the software. No, now, guys. Remember, this is the video, this is recording. Now, after that, you practice by yourself. You go to the internet. You go to the internet. Let me open my browser. Let me open my browser. Yeah, I want to share the browser with you. Okay. Okay, do you see? Let me share the screen of the browser. Switching to Google Chrome. Do you see my Google Chrome? Do you see my Google Chrome? No. No, not yet. Wow. Let me try one more time. Do you see my face now? Hi. Do you see?
Yes.
Now I want to share Google Chrome. Sharing. Do you see Google Chrome now?
Yes.
Okay, cool. Now I type in GeoGebra Classic. I don't want some student email me. No, I don't found. You don't found. It's saying internet. Look, GeoGebra Classic. There you go. This is GeoGebra Classic. You click here. There are several versions of the GeoGebra. There are several versions. Do you see the GeoGebra now?
Yes.
Okay. However, I don't want my computer working in that way because this is online. So I go to the cloud, and the cloud is a little bit slow. No, it's slow, no, but you know. Entonces now the other disadvantage is that I cannot saving in my computer the folder with the work I did before. Entonces my recommendation is download the application in your computer. Si you want, no, you can after you want reinstall, no. Si you when you finish the class with me, no. Okay, so now I want to close this browser. Okay, I open my application. Okay, I have here. I want to share with you the application. Okay, I have already installed in my computer because I suppose it's better either way. Okay. GeoGebra Classic. Do you see the application? My application?
Yes.
Cool. This application is graphic, but it's better than Desmos. Desmos, the only advantage of Desmos is too easy. This is a little bit complicated, not too much, but it's a little bit. Now the thing I want to explain is too easy. Pay attention, please. This is the keyboard, special keyboard. If you want, you close. Okay, let me maximize the window. You guarantee you see very well the GeoGebra? Yes or no?
Yes.
This is my application. This is not online. Not necessarily open now, guys. You open after. And you make a decision if you download or not. You go here to the 3 horizontal line and you select view. And when you select view, you see the different window that we can using in GeoGebra, no? But for this job, we don't need graphic no graphic. I click that. We're using algebra, we're using Gauss, and we're using a spreadsheet. Okay, what is that? Algebra is the piece of window or sub window in which you see the matrices. After when you create the matrix. No? Cast is the window que fantastic because allow us perform the operations. The operation que we are doing by hand. No by hand. We are doing this. And a spreadsheet is fantastic because allow me the matrix editor. Okay, let me close everything. Let me move in a little bit the window and put it that way. In any place of the spreadsheet is very similar to the Excel, no? You copy the matrix. You copy 3. Seven. I copy the original matrix I did by hand. Negative 15. You press enter. Okay, to navigate, it's similar to the Excel. To navigate cell by cell horizontally, you press tab and your own keyboard. And when you finish the row, you press enter and you change the row. This is 1. This is 2. This is negative 4. Enter. And this is negative 4 again. No, I make a mistake, no? Hello, I am crazy. This is 15 and negative 12. Remember the matrix in my problem contain 4 columns, no? Minus 12, minus 3. Okay, now, yeah, negative 4, minus 6. Now enter, I make a mistake. 15 and 16. Wow, I did a mess. Okay, this is my matrix. It's super easy typing that. Hello, right? Now, important crucial moment. You select every number inside the matrix. You press in the mouse the right click, and you see the menu, pop menu, and you create. Create what? Create matrix. Do you see the process? And when you create matrix, let's see what's happening. Bang! In the algebra, you see my matrix. And this is the moment, guys. See, I'm checking any mistake because everyone makes a mistake. I make a mistake all the time. You see, I forgot one sign, or you put the sign wrong, a different answer. Let me check it. 3, 7, negative 15, negative 12, 1, 2, negative 4, negative 3, negative 4, negative 6, 15, and 16. Good. I did well. Okay. Now, to solve the matrix, you go to Gauss and you click in Gauss. Let me see I remember is echelon, echelon, echelon. It's like that, echelon. Echelon 4. No, you don't remember? Echelon. Yes. Let me see. No, this is wrong. Carajo. I don't remember. I forgot something. Is elimination. 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 Oh, Gauss-Jordan was elimination. Elimination. No, I don't think so. Wow. I need to see the video. My video after that is I probably guess elimination. Oh. I don't remember. Let me see another page there. Let me try to find one video. I threw in my memory, but I forgot something. Okay, YouTube. Okay. My channel. Okay. Okay. In the list, I want to find in the same class, in the pre. Is matrix and determinant. No. IP 01. We copy this. And multiply like that. Negative 1 times 0 is 0. And 3 times 1 is 3. And then it's 3. And that's it. 3. Let's do it the second. Okay. I'm watching the same video. Basically, the conclusion before starts. It's supposed to be this. I don't remember the command. It's the idea. So we start for the easy. No. Perfect. Oh, there you go. And you go to the class. In class, you reduce a row. Reduce a row. And you type in RE. You reduce it. There you go. Reduce a row echelon 4 of the matrix. Of what matrix? Matrix que I call no. The software called M1. You put M1 and you press enter. Bang, and that's it. And you get directly the reducer row echelon 4. I don't remember reducer row echelon. You put elimination. Entonces es obvio que X es negative 1, Y is positive 3, and C is positive 2. Do you see or no?
Yes.
Okay. Let's practice this. Let's practice this. We have, let me try to find interesting example. Next time, I promise, I bring another example, no? To illustrate another new idea. This is good. This is very, very good. Suppose we go back, so we working in the whiteboard and the GeoGebra to solving a couple more of the example. I want to illustrate very well you the advantage and disadvantage of this. Let me try. Let me try to come back again to the whiteboard. And we start at the beginning. Oh no. Okay. Whiteboard is this. Minimize. Share. Whiteboard. There you go. Do you see whiteboard? Yes or no?
Yes.
Yeah.
Cool. Let me erase everything. Wow. And we start at the beginning. Look, suppose a system. Suppose a system. Let me try to find one beautiful example. Okay, this we did that, huh? Yeah. I like that. Suppose in the test I say you solving the system 2x minus 5y minus 21z equal 39. Equation 1. Equation 2 is x minus 3y minus 10z equal 22. Equation 2. And the third equation is x plus 3y. And the beauty, guy, is we can solving the any number of the equation. And we discuss in detail not today, next week, when you have different number of the equation and variable. Okay, it's a little bit more complicated, but it's doable. Suppose this system. Of course, I don't want to do by hand. No. I copy the matrix associated with this. The augmented matrix is 2, negative 5, negative 21. I put a bar to separate left and right hand side. And you put here 39. 1, negative 3, negative 10, 22. 1, 3 positive. 2, be careful with the sign. One sign you change is another problem different. By the way, this is the matrix is the dimension is 3 by 4. 3 equation, 4 column. The 3 traditional. And this is my matrix. I go to the GeoGebra. Okay. Maybe GeoGebra. Okay, I want to share the screen to the GeoGebra. There you go. Do you see GeoGebra?
Yes.
Yes.
Either way, you can edit another matrix or you can delete this matrix if you prefer. So you can delete, it's easy delete. You select the number that you want. Let me copy just in case. Copy. And you, for example, you select and you press in the keyboard, delete, bang, and that's it. It's gone. You want to restore, press this and put paste, and we have the new matrix. Okay, by the way, let me delete this. Okay, I copied wrong the commands. Yeah, I don't remember the command is reduce the row echelon. I don't know how we delete. I don't know. Well, maybe you delete the row. Yeah. Boom. Perfect. Either way, what way you prefer? Copy or erase everything in the previous problem? Copy new, no? Or no? We can, this is perfect editable. You can copy, paste, it's fantastic. Okay, look, I select this. Delete. I copy my new matrix. My new matrix is 2, negative 5. Negative 21. 21, not 12. 21. 39. no tap. You press enter to change the line. Enter. Ok, entonces es 1, -3, tap, -10, and 22. Enter. Last equation. 1, tap, 3 positive, tap, 2 positive, tap, and -8. This is my metric. Guy, help me to check in see I did well or not. Just in case, don't worry. You select, create a matrix, remember right click, create matrix, and you see more clear here. 2, -5, -21, 39, 1, -3, -10, 22, 1, 3, 2, and negative. I suppose it's okay. Now you put here, okay. Oh, clear, okay. Now you see the command now. Look, bam, bam, is reduce it. Let me copy here to don't forget anymore. The command name is here, reduce row echelon form. Row echelon form. The acronym is RREF, que es the same en the calculator. Entonces, reduce it. I don't know si we need capital letter or no. Reduce it. I suppose que no. There you go. Yes, we need capital, but when you don't finish to type it, you see the command. Of the matrix, you select the second option because open the parenthesis, allow me put the matrix. By the way, the matrix, if you want to change the name, you can do that. But it's okay. I want to show you now. MN1, and press enter. Bam! And look at the answer. The answer is x equals 7, y -5, and z is equal to 0. So after, okay, you put it as a software, and the software help me to understand much better the problem. I see. Let me explain detail this idea. Okay, this is the complicated part. Look, I come back at the beginning, at the whiteboard. Do you see my whiteboard? Do you see or no?
Yes. Yes.
Okay. Now, the thing I'm doing, and you indicate like that in the test. You put the arrow, and you apply RREF. What means that? Reduce it. Row echelon form. You get this matrix. Wow. New matrix. And the left hand side, we have 1, 1, 1 here, and the rest is 0. By the way, this matrix, everyone in the world know like the name of the identity matrix. Identity matrix. The reason of the name is not clear for you now, but I anticipate a little bit that this is because when you study with me the operation with the matrix, not this echelon, another operation, for example, multiplication of the matrix, when you multiply any matrix time, the identity is like a behave like a 1. It's, you know, it's when you multiply 1 times 20, it's 20, no? Similar situation happen in the identity matrix. No? Identity matrix, by the way, is indicated with the capital I. Multiplication by any matrix, suppose the matrix A is equal to the matrix A. And this behave like a 3-dimension or 5-dimension or multi-dimension. In this case, 3 because it's 3 by 3. 1. So it's like a 1 to the dimension 3. No the regular 1 que es dimension 0. Okay? No dimension 1, no 0. Entonces, you you have in the after the line, the vertical line, you have 7, you have -5 and 0. Therefore, the conclusion was okay, x is 7, y is -5, and c is 0. Correct? That 0 is a number, no? You can write if you want in like a triple order 7, -5, 0. Bam. And this is the scenario. Remember, in the linear system of equations, we have 3 possibilities. We have the possibility of the unique solution, only one, infinity many solution, or no solution. So I want to explain now how you can see infinity many solution and no solution in this new language of the matrix. It's amazing because when you are doing by hand without this technique, you know clear 100% how many free variable. See, we have only 1 or 2 or 3. It's confusing, very confusing. I understand. However, in the matrix organization, it's clear. See, we have 1 free variable or 2 free variable, and see, we have no solution or no. Let's do it one problem que es no like this, que es unique solution, is infinity many solution. And at the beginning, you don't know, of course, anything. And when you organize a matrix language and you put in GeoGebra indicates us the idea. Let's move. It's example 3, no? Example 3 is minus or positive? No, it's positive. It's positive. Is x minus 4y plus 7z 7c equal 14. This is my first equation. My second equation is minus 2x plus 9y minus 16c equal -31, equation 2. And my third equation is x minus 7y plus 13c equal 23. And this technique normally I am doing in 3 equations, but it's the same. In the next lecture we solving the problem in 4 equations and 5 equations, and the software solving in 1 second. But the most important is the interpretation of this. Okay, so I am doing use a matrix. So I set up my augmented matrix, que es the combination coefficients in front of the variable, and put the vertical line right hand side. 14 minus 29 minus 16 minus 31 1 minus 7 13 and 23. By the way, this matrix is 3 by 4 because we have 3 equations and 4 columns because the extra column of the right hand side. And you put inside the software. Now let's see what happened. What's going on? Okay. There you go. Do you see your algebra?
Yes.
Okay. I want to delete this. Now I select, press delete in my keyboard, done. Or right click, delete. You can apply right click and select the option delete, because I'm unable now because we have no number, no? Okay, so now I type in my problem. Okay, my problem was 1, -4, 7. 1, -4, 7, and 14. Enter. This is my first equation. My second equation is negative 2, 9, negative 16, and minus 31. Boom. This is my second equation. My third equation is the last one, is 1, negative 7, 14, and 23. Super. Now, I create a matrix. I select the number with the mouse. You press and hold the finger in the left mouse, no? A selection, exactly the same we are doing in Excel, a spreadsheet. You right click and you select create. And we have created different objects, but I need to create matrix. Boom. We are doing 3 times. I want to take advantage to explain one thing. Suppose that in another more complicated problem, because I promised that we are doing complicated problem in the future, you want to rename this matrix, you click here and you put rename. Right click, you right click inside the object and you rename. And I suppose that I want to call this matrix capital, que frequently in the paper, the letter that we use to denote the matrix capital. When you see capital in this subject, capital is matrix, and no capital is variable. So X, Y, Z is no matrix. And you change the name. You see that I change the name?
Yeah. Yeah.
Now again, I don't know anything, surprise. And I want to put reduce it. No, it's reduce it. I don't remember reduce it. Oh, reduce it row echelon form of the matrix. Now the name is I rename capital A and present it. Boom. I copy this answer. I need to interpret this answer. This answer I have in my paper here. 1, 0, negative 1, 2, 0, 1, negative 2, minus 3, and 0, 0. Ooh, what's going on? I don't understand anything. Look. I come back. I come back to the whiteboard. Okay. Look. I did my best. Do you see whiteboard?
Yes. Yes.
Okay. I did my best. I put in GeoGebra. I apply again, reduce the row echelon form. I get this answer. Whoa, it's complicated. 1, 0, negative 1, the vertical line that separates the coefficients in front of the variable on the right hand side number. 0, 1, negative 2, negative 3, 0, 0, 0, 0. What happened with the third equation?
Professor, I see the whiteboard.
Do you see whiteboard?
Oh, no, I see it. No, I see it.
You see? See, there are some delay, no?
Yes, it was still on the GeoGebra.
Okay. But you see now, no?
Yes.
Okay. Now, the answer I get in GeoGebra was this matrix. So now, interpretation. Okay, when you see 0, 0, 0, 0, 0, wow. What the hell is that? The interpretation is, listen to me, elimination process. Discover that the third equation is depending of another equation. I don't see using my eyes. However, mathematical language discover gets depending. Remember, depending is suppose you have 2x plus 2y plus 2z equal 4, and we multiply by x plus y plus c equal to, no? Okay, you know, Okay, when you multiply this equation by 2, you get the second equation. These equations are depending in 3 dimensions, represent the same plane, and do not apport extra information in the system. Okay, and when the situation happens, the most frequently is can we have infinity many solution, no unique solution, because unique solution we have when the 3 equations are totally independent. But at the beginning you don't know. However, the elimination process discover that the third equation is depending of the another. I don't know exactly what factor or what multiplication or what combination, linear combination you apply, but he discovered that. So you delete mentally. Your problem now is not like that. Your problem is like that. 1, 0, 0, 1, -1, -2, 2, and -3. This is my problem now. Oh, but where's the answer? I don't know, because normally, the format que normally I see before is that we have identity matrix in 3 dimensions or in 4 dimensions, and we have different number here, 2, 3, 4. And you, wow, fantastic. X is 2, Y is 3, Z is 4. End the story. One equation is gone. Don't not participate in the game. This give me information you believe that we have infinity many solution, no unique solution like that. This is classical format for the unique solution. But what is the format, Professor, for the infinity many solution? Well, you see again here identity matrix. But this identity matrix is the dimension 2. This is I2, capital I2. That was capital I3. Okay, by the way, it's a coincidence with the dimension for the system is 3 equations. But in this case, no. One equation is gone, and you have identity matrix dimension 2. And this indicates us that X and Y are non-free variables. And the only free that you can declare is C, que es the extra what? Extra block, que do not include inside the identity matrix. So this extra block, in this case only 1, but in another more complicated problem you can see that it's not necessarily 1, it's 2, 3. So this indicate me the amount of free variable is always the challenge to see algebraically. However, in this new organization of the matrix, wow, it's fantastic clear. The free variable is C. And remember, free means that this variable is ordinary number, any real number. So now how you express the final answer of this problem? Oh, easy. You take the equation 1. Okay, the equation 1 is the first row, que es x, 1x, no y, minus c, equal to, no? And you isolate non-free variable que es xy as a function of the free variable que es z. So x is 2 plus c. Likewise, in the second equation, we have no x, 1y, minus 2z, equal minus 3. Therefore, y alone, que es non-free variable, is equal minus 3 plus 2c. And how you write the final answer? There are many ways, two different ways, not many, two. One way is, my solution set, I know que es infinity many solution, belong to the 3-dimensional space in which you have x, y, and z component, such that x, que es non-free variable, is 2 plus c, comma, y, que es another non-free variable, is minus 3 plus 2c, comma, and c is to be better, is any real number. And the story. And the story is a one possibility. It's obvious. It's obvious. Okay, when you have one free variable, it's because actually the geometrical interpretation is we have the plane that represents one equation, stay alive, and we have another plane that represents another equation. Suppose this is equation 1, and this is equation 2, and the solution is obvious. This line is infinity point and represent like a line, and you know this the line because you have only one free variable. One free variable indicate us que the solution set, solution object is a line. A line is the geometric object that have only one dimension. Another possibility to indicate this answer, que frequently in Alex, they want you indicate you using X, Y, Z, no? But specifically in this example, X is 2 plus Z, comma, Y is minus 3 plus 2Z, and C is Z. We can see it free. This is equivalent to this, either way. Do you understand very well? Or no?
Yes.
Cool? Entonces, no excuse from now. You will be able to destroy any system. It doesn't matter that the system contains 5 equations, 5 unknown. You put it in the software, and the software are doing the algorithm. Gauss-Jordan. And Gauss-Jordan, maybe we have one format, okay, the typical unique solution. This one, when you have identity matrix. Look, what is the difference between this format and this format? Oh, the difference is that we have no extra green block, que es the guy que indicate the free variable. We have no free variable. Therefore, the solution is a point. It's a point 2, 3, 4. X equal 2, Y equal 3, and Z equal 4. Clear? Clear, right? No confusion. I promise that next time I bring no 1,000, but a lot of problems. Entonces now you try, because the algebra is no big deal for us. You put in the algebra, your configuration in the matrix language, you put in the software, and the software allow you, give you the answer. And the most important for me is the interpretation of this answer. Si es unique solution, si es infinity many solution, how many free variable, and no solution. Let's see one example of no solution now. Any question on that part? Do you understand how elimination process discover when the one equation is depending? And normally happen that when the one equation is depending, it's because we have infinity many solutions. See, we have 3 equations, and these equations are independent. Never we have one row with the 0, 0, 0. No, never. Therefore, we have unique solution. Let's see another example that brings me the third scenario, que es no solution. No? Let me try. No solution. No solution is, suppose this example is X minus 3Y minus 17Z equal negative 59, equation 1, X minus 2Y minus 12, C equal negative 41, equation 2, and this is minus 2Y, so X is missing in the last equation, minus 10C equal 20, equation 2. And this is my system, linear system of equations. To solve this, I create the matrix associated with that. Augmented matrix. Augmented matrix is a combination coefficient from the variable plus the right-hand side number. 1 minus 3 minus 17 59 is my first equation. 1 minus 2 minus 12 minus 41. Wow, too many negative. And 0, because this is missing here, right? Minus 2, minus 10, and 20. Again, having is 3 by 4. Okay, I copy in the piece of paper in matrix 4. I go to the software, put in the matrix editor that number, convert to matrix, this array, and apply the reduce row echelon form. It's doing. Is okay. Algebra now. Switching to algebra. You see?
Yes.
Okay. I select this and delete. You can stay and copy another. Let's do it by curiosity. In another play, in the play, not necessarily down. It's totally free. You copy 1. Let me use my keyboard. 1 minus 3 minus 17 minus 59. Enter. I finished my first equation. 1 top minus 2 top minus 12 top minus 41. Enter now. And the last equation is 0. Be careful when the one variable is missing. Minus 2 minus 10 and 20. Guys, I am doing too slow because everyone making mistake. It's a frequently happen. The student don't pay attention, try to type in. See, you type in different number, or you type in different order, or you type in different sign, you are doing another completely different problem and don't expect the same answer. Okay, now you create a matrix, create matrix, and default the software put matrix 1, M1, M2, M3, M4. So you like this, it's okay. So you don't like, you change the name, rename. Okay? Do you want rename or no? Not necessary. No. Entonces now again you type in reduce it. I don't remember very well si es capital or no. ¿Es capital or no? No necessary capital. Reduce it. There you go. You don't finish to typing and you see the command of the matrix 1, no? Que es the matrix que you see in this example. Bang! Yeah, I get this answer. Wow, what the hell? What the hell? Oh, let me see. I get different answer, no? Let me copy my piece of paper because I see different answer in my piece of paper. It's 1 0 0 0 1 0 negative 2 5 0 0 0 1. Let me see if I make a mistake. 1 negative 3 negative 17 negative 59 1 negative 2 negative 12 negative 41. Yeah, I copy right. Okay. This is the answer. Okay. I respect this answer. Okay. Now I come back to the whiteboard to copy an interpretation this. See, we have infinity many solution, no solution, or unique solution. Okay. Okay, there you go. Whiteboard. This is my whiteboard. Do you see?
Yes.
Okay, so you apply now again RREF. And you get that matrix. 1 0 0 0 1, 0. Negative 2, 5, 0. The line, in the software you don't see the line, but it's okay. I put a line to separate, 0, 0, 1. And this is different to another example because remember in another example we have one entire row que es 0, 0, 0, and I delete this. In this, the last equation, no is 0 because we have 1 here, or not necessarily always one number, 20, 40, negative 1. But I need to understand the interpretation of this. The interpretation is, suppose the row 3, I copy separately. Remember, this is the column of the X, this is the column of the Y, this is the column of the Z, this is the column of the right-hand side, and you copy 0x plus 0y plus 0c is equal 1. Do you see that? This equation? How we translate to the matrix language backward to the equation. The subject is 0, and 0 equal 1 is totally false. It's a contradiction, and the interpretation is no solution. Cool? No solution. It's a 3 scenario that we have. Let me recap quickly in the time we have, in the 10 minutes we have. We have 3 possibilities. Unique solution. Infinity, many solution, and no solution. No solution. I want to put a complicated example, but no. I put it, the answer. Solution. Suppose that we have a system that contains 4 equations. After the simplification and reduced row echelon, you get this 1, 0, 0, 0, 1, 2, 3, 4, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and we have in the right hand side 20, 30, 40, and 50. So what is this scenario? Well, okay, I can see here the famous identity matrix. How you identification identity matrix? It's a matrix that the main diagonal is just 1, 1, 1, 1, 1, 1, 1, and the rest is 0. This is identity matrix of the dimension 4 because it's a square matrix 4 by 4. So 4 row, 1, 1, 2, 3, 4, and 4 column, 1, 2, 3, 4. Therefore, it's obvious because the name of the variable is x1, x2, x3, and x4. Or normally, in this subject, they call different. They call xy, c, and w. W is the third one, or whatever you want to call it. Es obvio que x is 20. Es obvio que y is 30. Es obvio que z is 40. And it's obvious that W is 50. And this is a typical scenario of the unique solution. Clear or no?
Yes.
Aha. Now let's move on to the complicated case infinity dimensional solution. The students don't understand very well. Suppose I want to complicate your life. I put the example like that. And we have, after the echelon, we have one number here, 5, 6, 7, 8, 10, 11, 12, 13. And this is the line. And we have another number, 20, 40, 30, and 50. Okay, what the hell? Because I don't know, I am lost. Therefore, I immediately try to identification the identity matrix. Take this. Similar to this. But this is the, let me call, because we have several variables in the problem, x1, x2, x3, x4, x5, and x6. And this is the right-hand side number. So we discover another two extra block. Que is this and this after the reduced echelon form. Therefore, I can infer que the variable, the non-free variable, are x1, x2, x3, x4, and the free are x5 and x6. In order to find that, you have two free variables. So now, this is the solution is the weird object in the 6-dimensional space. It's impossible to see graphically, but algebraically, yes, 6-dimensional space. In which is the dimension 2 is a hyperplane. Dimension 2 is a plane and the 6-dimensional space. Well, but the problem is how you write the final answer. Well, the final answer is, remember, we have x1, x2, x3, x4, x5, x6. Separate by comma, no? Component. However, in the equation number 1, in the row number 1, I see que the relationship is que x1 is equal 20 minus 5x5 minus 10x6. In the equation 2, in the row 2, x2, is this number 1, is equal 40 minus 6x5. And remember, x5 and x6 is a free, it's already a number, minus 11, x6. Okay, now x3 is 30 minus 7 x5 minus 12 x6. And finally, in the last equation, x4, remember this is non-free variable, this is non-free, and here is a free, non-free, and this is a free, is 50 minus 8x to the x5 minus 13 x to the 6. So now you leave it like that, or you write this equation in this place. This equation here. This equation here. This equation here, and x5 and x6 leave it like that because it's a free. Do you understand the idea? Confusing? This, in my opinion, this is the most complicated scenario. Another solution, let me try to explain one format for the no solution. No solution, no solution, no solution. No solution is, look, no solution. No solution is easy to see because, for example, you have 1, 0, 0, 0, 1, 0, 0, 0, 0, and you have 20, 30, and 40. Okay, something like that. Well, in this case, you see again the last equation, we have a contradiction because remember this line represents equal sign. This line represents equal sign. And 0 is equal 40 is a contradiction, totally false, no solution. So my recommendation is always try to see the last equation, the equation in the last row. Because sometimes it's like that, or sometimes it's like that. Suppose que 0, 0, 0, 0. Oh, it's different to this. This, you eliminate this, and you analyze, only this. Because this is depending, it's not important participate in the system. Now you see that this is the identity function dimension 2. And we have extra block que represent the free variable, que es, in this case, is x and y are non-free and c is free. Entonces, typical infinity many solution. So, you write x, y, z, but in the x component you write 20, x is equal to 20. Well, no. I suppose that in this case we have a number here. It's a hypothetical, you know, it's a 5 and 7, ¿no? Entonces, no, si es 5 and 7, que es de extra block, si es 0, no. Entonces es x is equal to 20 minus 5c, y is equal to 30 minus 7c, and c is c. And it's an infinity many solution. Do you understand the idea or no? Of course, we need more practice. We practice in the next class, and we practice in the review that I prepare for you. Fantastic review that I prepare for you. Okay, guys, too much. I wish you, for everyone, happy Thanksgiving. Enjoy, relax, disconnecting. No school, at least this weekend, no? I will enjoy this.
Have a good break.
You have happy Thanksgiving. Bye-bye.